All right, let's see, either I need to change my stool or I gotta set it up. Alrighty, what may happen if a transmitter is operated with a microphone gain set too high, and I might say you might also be speaking too close to the microphone. It might become distorted. Which term describes the ability of a receiver to detect the presence of a signal? So, can I ask here can you pick out the dumb ones or pick out which two might be the one you're going to have to struggle with?
I think D is kind of weird.
D is kind of weird. I like that. Okay, so
Harmonic distortion.
yeah, let's take out harmonic distortion. Yeah. I don't know. Did we talk about linearity at all? No. So let's cross that one out. So we're between sensitivity and
I
selectivity.
think it's B.
B. To detect is going to be B, yeah. Very good, because that often confuses people between the two. Which of the following can be used to enter the operating frequency on a modern transceiver? Is it a keypad or the phone knob? The CTCSS or the DTMF encoder. Remember talking about that? The automatic frequency control, or all of these choices are correct? A. I would even sit here and remove that more and put hand in there. I don't know, maybe on the new test thing when it comes out in July, very possibly they may change that to keypad and the phone now. What's the purpose of the squelch control on a transceiver? Set to the highest level of volume desired, set the transmitter power level, adjust the automatic gain control, or mute the receiver output noise. Excuse me, goodness sake, where did that come from? Mute the receiver output noise when no signal is being received. Here's another one. Stop it. And which one do you think it is? D. D it is. What is a way to enable quick access to a favorite frequency on your transmitter? Transmitter. We'll talk about transmitters someday. Is it do you enable the CTCSS tones, store the frequency in a memory channel, disable the CTCSS tones, or use the scan mode to select the desired frequency? Well, we're talking quick access, so it's B. Which of the following would reduce ignition interference to a receiver? So ignition interference sounds to me like we're talking about a radio that's been installed in an automobile. So which of the following will reduce that? Change the frequency slightly, decrease the squelch setting, turn on the noise blanker, use the RIT control. C, turn on the noise blanker. Which I think might be a yes. Very good. And that'll really be on the fancier radios. Your mobile radio actually probably won't have a noise blanker on it. Although you can be in a base station in your shack, in your house, and your neighbor starts his car, it is possible you will hear his ignition noise interfering. Okay, which of the following controls could be used if the voice pitch of a single sideband signal seems too high or too low? Would I use the AGC or limiter? Would I use the bandwidth selection? Would I use the tone squelch? Would I use the receiver RIT or clarifier? Now, we didn't talk about that, but this is the term that the IAC radio uses for the RIT. They call it a clarifier. Anybody want to make a list? Anybody want to point out dumb ones? I don't think it'll be AGC, remember. But it will be the RIT. Receive incremental feed. So maybe he's slightly off frequency. I might use that. cause I still wanna transmit on my frequency. Okay, what does the term RIT mean? Well, it just said it. Who remembers? What's the advantage of having multiple receive bandwidth choices on a multi-mode receiver? What are the advantages? Bandwidth permits monitoring several modes at once. Permits noise and interference reduction by selecting a bandwidth matching mode. Increases the number of frequencies that can be stored in memory. Increases the amount of offset between receive and transmit. There's a bunch of them here I'm not too sure about. Anybody want to take a guess? Which? B, C? I'm hearing two. I'm hearing B's.
I'll go with B.
B sounds pretty good. Permits noise and interference reduction by selecting bandwidth matching mode.
Even a blind squirrel finds enough once in a while.
Yeah. Which of the following is an appropriate receive filter bandwidth to select for minimizing noise and interference for sideband reception? Now, you gotta remember, sideband reception, how broad is that, sideband, frequency? How far does it stretch? Remember what on an AM signal, what that total was, and I take half of that? So we're talking 3 kilohertz or 3,000 hertz. So you want to select something for minimizing noise and interference. This might be too narrow. This is definitely too big. So it's one of these two in the middle. C could be good. I would do that. Good choice. Which of the following is an appropriate receive filter bandwidth to select for minimizing noise and interference for CW reception? Now, how wide is a CW signal? It was really narrow, remember? 150 hertz. So, this is gonna be too big. All of these are too big. This one, probably gonna be your best bet. What's the function of automatic gain control, or AGC? Does it keep the received audio relatively constant, protect an antenna from lightning?
Yeah.
I like D.
Thank you all for that. D is an asymmetric bond denominator control for so what does that leave us, to eliminate RF on the station signal? That's not gonna do that. So,
Protect your antenna from
what's it gonna be? Y'all say A?
I say B.
You would. All right, very good. Oh, no, well, here, I haven't put it in here. What's a goniometer or whatever, however you pronounce it. Cocktail trivia.
Huh.
There you go, now you know. Don't tell anybody you didn't learn anything from me.
So,
Okay, what is meant by the term PTT? Push to talk. What device increases the power, the low power output from a handheld transceiver? Is it a voltage divider, an RF power amplifier, impedance network, or all of those above? B, I'm hearing B. Very good. What can you do if you are told your FM handheld or mobile transceiver is over deviating? Should you talk louder, tell the transceiver to cool off, or let it cool off? Change to a higher power level, talk farther away from the microphone.
talk louder.
Go sit outside. Okay, B, talk farther away from the microphone, or turn down your microphone gain if your radio has microphone gain. We need to turn this gain down. Or we're going to use the attenuation control as we turn it up on here. Okay, what's an electronic keyer? So is this a device for switching antennas? What we're talking about here, so, we're talking Morse code. Device for voice activated switching, device that assists in manual sending of Morse code or an interlock to prevent on-off use of the radio. Yeah, because it's a key, right? Okay, so it's a device that assists in manual sending of Morse code. All right, let's talk a little bit about digital communication. I'm going to try and breeze through this one fairly quickly. Computers and the ham radio. Yeah. Computers have really taken over everything. Now, AI is also invading this space. And there's just all kinds of ways to integrate all of this into a ham shack. So this guy's got, oh gosh, dozens of different things going on here. Some of it is dealing directly with communication. Some of it might be, tell you the truth, I don't see any logging software. But that's another thing we can be doing. Keeping, record keeping a radio contact up, operating digital modes, sending and receiving CW, operating remotely via the internet, controlling accessories like antenna switches, rotatable antennas, the list goes on and on and on. And it doesn't, I don't see anything doing with satellites up here, but as technicians, you guys can talk to satellites, and there's a lot of ways to do it, but if you've got a really fancy radio that will transmit on satellite frequencies, managing where to point your antenna as that satellite moves, handling the Doppler shift on the frequencies, the computer will do all that for you if it hooks up to your radio.
And also real quick, this handheld here, the VGC, you can control it by the phone app as well. What this will do is when you hit track satellite, it'll automatically put the uplink and the downlink, the transmit and receive frequency in the radio for you. And as that Doppler is changing, it will change the frequency automatically for you. So you don't have to worry about programming the 5KC, so 145, 5/8. You don't have to worry about knocking that down. This radio does it automatically for you.
Digital communication, so digital communications, ones and zeros, are converted to audible and sub-audible tones. Similar to voice, these tones are modulated for transmission. There are protocols out there that dictate how digital info is packaged and exchanged. Some digital modes can automatically error correct. Data can be exchanged at higher rates than voice, and a gateway computer interfaces radio signals to the internet. Don't confuse this with gateway computers, which I understand gateway's out of business now, is that right?
Oh, yeah.
Shows you how old these slides are, and this slide or this question may not be in the next data pool. We'll see. So why digital modes, really? You got all these ways to communicate, particularly if you've got a microphone and headphones. But two of the stated purposes of having an amateur radio service in the USA are advancing skills in the technical and communication phases of the radio art and contributing to the advancement of the radio art. So learning to use any of these digital modes really does meet both of those purposes. And this is why, again, with a license, you can do so many things that other radio services just can't do. Reliable communications using less power and smaller bandwidth can be more efficient than even sideband or CW and this digital communication stuff is constantly evolving, so that previously discussed PSK 31, boy, is that old. That is really old, and like I said, nobody hardly uses PSK 31. There's so many other better digital modes out there, that the older ones aren't being used. Except Morse code. This is the original digital mode. On or it's off. And it is still here, and as I mentioned earlier, since it's no longer required, it's become more popular. Can't explain it. Yeah. Data modes, let's see, systems exchange data over the air between two computing systems. Email, digital files, keyboard to keyboard typing. These new protocols and modes are created by amateur radio experimenters. Information exchange has individual characters encoded as digital bits as zeros and ones get modulated onto an RF carrier. Recently, I think it comes up here, things like FT8, that comes up, so I'll mention it when that one comes up. Data modes. Historically used specialized modems are teletype terminal units. That's the old teletype. Remember, you see them maybe in pictures and on old TV things, but great big clunky things. Clatter, really loud, and we still use those. We call this RTTY. RTTY. Terminal node controllers, TNCs, that is the more common thing we used back in the old days. Multiple protocol controllers, and I'm not too familiar with that myself, but these days computer sound cards are used instead of these things up here. So signals get routed through the computer audio to the mic's radio's mic, converts received audio to a digital form, and sometimes your computer USB will make a direct connection. This will all be with recent radios, because the old radios, I can tell you, do not have USB connections. Okay, popular modes, RTTY, the teletype. They still have, once a year, there's a teletype contest. How many stations can you contact on RTTY? PSK 31, I hesitate to say that's popular. I think it's gone out. JT65, moon bounce, and MFSK for meteor scatter. These are two modes if you want to get into moon bounce or meteor scatter, and we talked about this meteor scatter back in, I touched on it last week on propagation and modes like that. Packet radio used for emergency communication, which is also WinLink. Now they're calling it WinLink. Not many people are calling it packet radio anymore. APRS uses it with GPS. This is popular if you're into that kind of thing. You bring up a application that has maps, like Google Maps, and it will overlay radio station locations. And so if your radio is transmitting an APR signal, it will get overlaid onto those maps, and you can follow where you are. Okay, having been, I'm a retired State Department Foreign Service officer. I do not want to be tracked. I do not use APRS, but a lot of people really like this. If you are working bicycle races, for example, doing community service events, for a net control station to know where his radio operators are along the course. APRS is actually a very good thing. I know somebody is near this report that a bicyclist has broken his chain and may need assistance. Can you go check it out? You're the closest one, I can see from APRS. You're the closest radio station, so.
Back in the early nineties, when I got the communication started for the Tour de Chesapeake, that's how we used APRS, because some folks could not hit the repeater, but we had an APRS digipeater set up, and I was able to locate where the SAG vehicles were, and to see where the last rider was, and it was very helpful. We were able to send messages through APRS, say, I need a mechanic down here, or I need fire and EMS for someone that fell off their bike, and that would get back to the mobile command unit, and we were able to call the proper authorities.
So it's got its purpose. Data station setup. Usually there might be an audio interface. If your computer has a sound card, it might not need any of these two devices, the PNC or an audio interface. You might just be able to USB cable connect it up. But you still need to get audio back and forth from your radio, so there'll be a couple of ways to do it. Audio goes both ways on the push-to-talk controls. Here's a PSK31 keyboard to keyboard. So keyboard to keyboard means you're just directly communicating from my radio to somebody else's radio, not going through the internet. And here this is coming in, somebody's calling CQ. I want to talk to somebody from DK5IZ. DK would be a German station. Please come back to me, over. And so he's making 2 more calls out here trying to find somebody who will talk to him. So whoever this is, he's got his mode in PSK. It's not USB, it's not sideband, it's in a digital PSK mode. And he's got his thing set here. Oh, well, he might be transmitting himself. Anyway, this is what PSK31 looks like. RTTY, look at these old clunkers. I got a friend of mine, you guys have got to see his house. He loves to show off his house. His whole house is a radio museum. Each room is a different decade, and when you go into his room, that is the 1960s. He's got 2 of these RTT things, TTY terminals in there. He's got radios from the 60s. His bookshelves are full of 1960 publications. It's quite a thing.
Keep the 3 on the side,
Which one, this one?
there, and on the other side to the left. And the middle one,
Yeah.
the top middle picture, to the left, there, that black part, that's a key tape reader.
Right, right.
You have to butterfly the tapes out to keep them preserved. Good stuff.
You don't look that old. Okay, so originally RTTY used mechanical teleprinters, but these days we now use computer sound cards to do all of that. And there are now radios that it's built into the radio. You don't need your computer. You might need to plug in a USB keyboard into your radio, but radios do the whole thing. Packet radio or WinLink or VARA, I think it's also now being called on a slightly different thing. Information is encoded as packets, a group of letters and then sent out as a single transmission instead of one character at a time. So a packet consists of a bunch of characters. Each packet has a header, there's data, and there's a checksum in there. The headers include receiving station's call sign. Errors at the receiving trigger an ARQ, an automatic repeat request. So this mode has data error capability. Anyway, the important thing to know here is the TNC is between the radio and your computer. The other important thing to know, and this could be a question, is this mode does error correction. Here's one of the newer modes, digital modes, created by Joe Taylor. Joe Taylor, K1JT. His suite of software called WSJTX. This is where you will find the moon bounce and moon to earth JT65 mode, weak signal propagation deepens FT8, meteor scatter uses MSJ144. That's all in his suite of software. Easy to download, he keeps it up to date quite often. And I gotta tell you, FT8, now it calls it a beacon, but it's more than a beacon. You actually communicate back and forth. But it's not a conversation you're having, it's, you have programmed information that gets bursted out. The other station receives it and acknowledges that, hey, I got your signal and here's my information, and it bursts that back to you. Your software will acknowledge the receipt of that and say, thank you very much, contact is over. And the other one will also acknowledge, thank you very much, and that's it. So you're not really talking, it's the software is going through a sequence. It's pretty easy to use this mode, and hence, what I have it here is at the next slide. I call it digital crack. It's addictive. It is addictive. I've fallen into FT8 and I'll sit at my radio and instead of getting on sideband and trying to work that Bulgarian station on voice, if I get them on FT8, I'd rather do that. Don't ask me why. And then this is the screen down here that does all of the sequencing of your messages. This is showing you where the signals are and where I might want to put my transmission. So also FT8 is extremely efficient. This represents 3 kilohertz of bandwidth. And I can get easily each one of these bands is representing a station transmitted. I can get 20 different transmissions into 3 kilohertz of bandwidth, which is incredibly efficient. So anyway, digital crack, FT8. Moon bounce will look something like this. I've never done it, but there are a lot of people out there who like that challenge, and it is a challenge. APRS, so here's the map with an overlay. Sorry, this is for classes I was teaching over in Williamsburg, so this is on our peninsula, but I can see K4NROs over here, here's ZIN repeater down here. Jerome K8LF, and then down in Virginia Beach, we're following N4AJR as he travels along whatever road that is down there in Virginia Beach around Lynn Mall. So APRS keeps track of everybody. Internet gateways, so this is becoming a very popular thing. If you've heard of D-Star, which Ellen was talking about earlier, DMR, all of the, Chinese radios have DMR and, System Fusion or C4FM on the IAC radios. If, and Earthlink and Echolink and, Allstar, also, uses gateway computers, to get into the internet and transmits. You might use a, radio signal to transmit to one of these gateway areas, computers connected to a radio, to get over to, at the opposite end of the internet, get to somebody else. So with your handheld, connecting to a repeater locally here that has Echolink, you could very easily talk to somebody in England or South America or California or any place if they're also on, similar Echolink channel. Message forwarding, so it can also, particularly with packet radio, messages can be, forwarded. How might a computer be used as part of an amateur radio station? For logging contacts and contact info, sending or receiving CW, generating, decoding digital signals, all of the above. Yeah, it's all of the above. How's a computer sound card used when conducting digital communication? Sound card communicates between the computer and the CPU and the video display. The sound card records the audio frequency for video display. Sound card provides audio to the radio's microphone. Input converts received audio to digital form. See, definitely. So you're noticing here too that, often when you were in school, all of the above choices was usually the right answer. As you see here, it's only been one or two that have been the D choice. What name is given to an amateur radio station that is used to connect other amateur radio stations to the internet? Well, here, A, gateway. Which of the following is a digital communication mode? Packet radio, IEEE 802.11, JT65, all of these. Definitely which one? Definitely A. Any of the other two? JT65, that was moon bounce. We didn't really talk about IEEE 802 because that's Wi-Fi, computer stuff, but JT65 is also a digital communication mode, so all of these choices are correct. What does the term APRS mean? Oh, this would be fun. Advanced Roller Radio System.
Yeah, that's it.
Auto Planning Radio Setup. Associated Public Radio Station Automatic Packet Radio Computer System. Okay, so I don't hear anybody laughing with me. Which of the following devices is used to provide data to the transmitter when sending automatic position reports from a mobile amateur radio station? Which of the following devices is used? The vehicle speedometer? A WWV receiver? Connection to a broadcast FM subcarrier receiver? Or a global positioning system receiver? Which one? D, okay. WWV, anybody here? WWV? That's out in Denver. They tried shutting that down, and there was so much opposition to it, they kept it open. WWV constantly transmits a radio, a time signal, all the time. It's usually on 10 megahertz, 15 megahertz, a couple of others. but, there's always that tick, 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 ding, at the tone.
At the sound of tone, the time will be,
And sometimes they got other, Canada had CHU, and they just shut it down recently, permanently. Okay, so definitely another vehicle speedometer either. Which of the following is an application of APRS? Real-time tactical digital communication in conjunction with a map showing the location of stations. Showing automatically the number of packets transmitted via Factor during a specific time interval. I don't think we talked about Factor, but that's another very old system. Providing voice over internet connection, providing information on the number of stations sent into the computer. All the dumb ones. Any guess? God, am I coming with these hiccups? Any guesses? A. Yes, indeed. Real-time tactical, showing locations of stations. All right, what does the abbreviation PSK mean? Pulse shift, phase shift,
B,
packet short, phase slide queue, but B is it, thank you. What is FTA? Digital crack will not be a choice on the test, I guarantee you. Wideband FM voice mode. Digital mode capable of operating in low signal to noise conditions that transmits on 15-second interval. An 8-channel multiplex mode for FM repeaters. Digital slow scan TV mode. Maybe we didn't talk about it that much, but it's B. Every 15 seconds it transmits sometime. Which of the following may be included in packet transmissions? Okay, this is one where I said it does automatic error correction. So there's a checksum which permits error detection, a header which contains the call sign of the station, automatically repeat request in case of error. So it's all of the above. What is an AR2 transmission system? An automatic request. Resend something. Special transmission format limited to video signals. I don't think so. System used to encrypt command signals to an amateur radio satellite. I don't remember talking about that. Digital scheme whereby the receiving station detects error, sends a request to the sending station to retransmit the information or a method of compressing the data. So basically automatic request. Please resend that. I missed it. What code is used when sending CW in the amateur bands? The Hammond code. The Grady mode. So obviously C. All right, power supplies and batteries. I think this will be the last one. Power supplies. Most modern radio equipment runs from 12 volts, although the preferred voltage is 13.8. Household AC power is 120 volts AC, so power supply needs to convert that, if it plugs into a lamp, to a regulated filtered 12 volts DC. Uses a regulator circuit to minimize voltage change. We want that to be a steady, well, I'm going to say a steady 13.8 volts, but 12 will also be the answer. If it drops below a threshold voltage, usually like around 10 and a half, the radio will automatically turn off. If it goes above, I've never seen anything go above 13.8, but it's possible. Sometimes you can adjust certain power supplies and go a little bit higher, but I wouldn't do it. Looks like somebody's got this one down here at 14.1 volts. Don't know why, unless it's a really long distance. There will be voltage lost over a long distance. So when you set up a power supply if your radio requires one, the shorter the better. The closer you can put the power supply to the radio, the better. So this one might be a very long lead voltage loss by the time it gets to the radio, the 13.8 possibly. And the amperage right now, it's not putting out any amps, which means it's, nothing's drawing any voltage from it, or any current. Types of power supply. So we talked about linear supplies, that great big heavy one, comes with that iron transformer. But it doesn't transmit any radio frequency. And this one happens to be an Astron with meters. I don't think that one over there has any meters. Switching supplies, and this is an Astron also, they make switching supplies. Uses electronics instead of transformers, but it can transmit RF. It's not properly filtered. Again, Astron is a pretty reliable, pretty good name brand. Although I noticed this one, unlike that one here on the table, does not have a knob for adjusting the RF frequency that it transmits. So that would mean it's pretty heavily filtered internally. Power supplies, two main ratings. You want to know about the output voltage, and you want to know how much current it can continuously supply. So on the continuous duty, this is an important thing. If I'm going to key down on a radio that needs 8 amps to transmit, I need that 8 amps for the entire transmission until I let up. On any power supply that is rated at 8 amps or higher, it will give me that power. But if I've got something lower, like there are 5 amp supplies out there, it might be able to give me 8 amps for a few seconds, but then it's going to cut back to 5 amps, and my radio is not going to be happy. This one over here, the big linear, is 12 amps, so that could do it. And then it's got 4 amps to spare, so if I have some other radio or some other equipment that requires 4 amps or less, I could plug that into that power supply as well. Intermittent duty, how much current can be supplied for short surges? That would be voice peaks. So on a voice peak, requires more power to put into that, particularly we're talking AM transmissions. It's going to surge to produce that extra power. A regulated supply, boy, always pick a regulated supply. That the internal circuitry makes sure that if it's rated for 13.8, it will always put out 13.8 volts. And when you're putting something out for the shack, make sure all the equipment that you've got in your shack that's going to require power, external power, is added so that you get a big enough power supply. I might advise, as you guys get your shop set up, I would look for minimum 20 amps. 30 amps will take care of any future needs. There are 50 amp supplies out there, really expensive. I don't think you need 50 amps, but 20 to 30 is good. So that current rating in amps needs to at least be the sum total of everything you're going to hook up to it. Consider the efficiency of full power, receiver and control circuit power needs, power supply regulation, heat dissipation, any other equipment. And equipment manuals always states the current consumption, everything. If it plugs into your wall or if it requires external power, that manual will have power consumption in the manual someplace. Maybe it'll be on the back of the radio. So mobile installations, this is a rather complicated looking thing. here's a chassis, here's a control head. This is a modern radio where the control head can separate from the chassis. A lot of radios recently, mobile radios, do it this way because your cockpit has become so crowded with nice things or great big fancy center consoles. Used to be on your '68 Chevrolet. A lot of room under the dashboard to attach radios. No more. So now the chassis itself may go under the seat, may go in the back of the trunk. A cable will connect to a control head up front. And that control head can be a very small thing. And the mic's up front. Tuner, you're only going to have a tuner if you are working HF. If it is strictly a UHF, VHF, there'll be no tuner. UHF, VH antennas are already pre-tuned. I guarantee you buy it at the store or even, at a ham fest. If it's UHF, VHF and it's for 2 meters and or 70 centimeters, a multi-band antenna, it's tuned. You don't have to worry about it. But if you're going to go with HF, you will need a tuner. The firewall is assuming that your battery is in the front engine compartment. Fuse both ends close to the battery and again close to the radio. You're doing that because if you don't use a rubber grommet where you're going through the firewall, and if the firewall itself is metal, if those cables, power cables, start to rub against the metal and chaff, you will get a short. And depending on which of the two, you want to have fuses on both the positive and the negative lead. But more importantly, if you're doing it that way, you want to make sure that you're using a rubber grommet in between. Some cars, my car has the battery in the trunk, which is where the chassis is. So I don't have to worry about that. And it's pretty close to the battery. Easy connection. I have one set of fuses only. Kind of a weird looking cabin, but that's the way they got it. Mobile power supply safety. Mobile radios usually require at least 12 to 13.8 volts are what mobile batteries are rated at, as well as your power supplies. Car batteries hold lots of energy, so shorting a battery could be really bad news. Bad juju, don't do it. Special requirements for safe car wiring. Use grommets or protective sleeves to protect those wires. Don't assume all metal in the car is grounded, because sometimes you might need a long lead on the positive on the red wire, but the black wire, the negative lead, boy, all you gotta do is just find a bolt or something very close to the radio and connect it, because usually the chassis is negative. And that was very true for the older cars, but today's cars are plastic or they're ABS plastic or lots of things that not always now going to that 1 volt very close to the radio means that it's going to be grounded. So you might have to test that, or if you get that all hooked up, it doesn't work. You're probably going to have to string a black cable all the way to the battery. Fuse both positive and negative leads near the battery. Connect the radio's negative power lead to the battery's negative terminal, or where the battery connects to the vehicle body. Use heavy gauge wire. Always use heavy gauge wire, even if it's not mobile. Use as short a wire as physically possible because there will be voltage drop over long runs. That alternator whine. I've heard it. Noise caused by the car's electrical system. You might hear it on receive. You hear that little whining noise in the background when the other person is talking. More likely others will hear it when you transmit, if it's your car producing that whine. A lot of the modern cars now don't do that. But I'll tell you this, even with my squelch set, if I'm at a red light, all of a sudden my squelch will break, and there's no transmission coming through. And when I look around, 9 times out of 10, there's a Honda at my back rear quarter, near the antenna where I got it, because those Hondas are noisy. And or I might be traveling along and all of a sudden there's a squelch burst, but no transmission, because I'm being passed or I am passing a Honda. So, not alternator whine, it's just, their computers are putting out a lot of noise. The batteries create current through the chemical reaction of, whatever chemistry, the battery is. Batteries have what they call cells inside the batteries. And, the manufacturers put those cells together in parallel or in series. Automobile batteries, there's sometimes 6 or 8 caps. Each one of those caps is a cell. So car batteries will have a bunch of cells. But even your batteries, I think there's a picture of a 9-volt battery coming up here, have little cells inside those rectangular cases. Cell chemistry determines the voltage. Battery types and some examples. So the disposable ones, we always like alkaline batteries. Lithium is now pretty much the rage. Carbon zinc, that's long gone. But those are chemistries. Rechargeable NiCads, lithium ion, which are causing airlines and everybody so much trouble if they can catch on fire when they're charging. And car batteries are lead acid. And storage, rechargeable lead acid batteries are pretty good, but lithium ion does a real good job holding their charge when you store it. So here's a 9-volt battery. It's turned upside down and the end's been pried off. But these are all the different cells that are in a 9-volt battery. So these batteries are a collection of cells. And depending on whether it's in parallel or series or both, can determine how much voltage it's going to output and how long it will be able to output that charge. Batteries are classified by electrolytic type, which we just went through in the previous slide. And here's a whole bunch of pictures of different types. Lithium ion, diesel dyes, Duracells, lots of stuff. So rechargeable batteries, best to avoid charging too quickly or overcharging them. Sometimes with the handhelds, they come with a desktop charger that does a really good job. But the wall wart chargers are very slow. And those are good ones to do, but you might not get much feedback on whether or not is it fully charged or not. But the desktop chargers charge faster, but also tells you when they are fully charged. Storage batteries like the lithium ions can release flammable and explosive hydrogen gases. Don't short them. Different battery chemistries need different methods of charging. So, if I have a lead acid gel cell, I can't use the lithium ion charger to recharge the lead acid gel cell. The nickel metal hydride will not recharge an old NiCad. It may up to a point, but then it's going to stop. Lithium phosphate, boy, you want to be real careful with those. Great batteries, but recharging, overcharging can also cause very serious problems. All right. SWAT must be considered to determine the minimum current capacity needed for a transceiver power supply. Efficiency of the transmitter at full power, receiver and control circuit power, power supply regulation, heat dissipation, all of those choices are correct. Yeah, all of those choices are correct. What's the source of a high-pitched whine that varies with engine speed in a mobile transceiver receive audio?
A Honda.
Good answer.
Good answer, I like that answer. Otherwise, which of the four up here would we have to pick? LPP. Where should the negative return connection of a mobile transceiver power cable be connected? That's the black line. Red is usually positive, black is always negative. So should that be connected at the battery or engine block ground strap? At the antenna mount at any metal part of the vehicle through the transceiver's mounting bracket. Which one? A. I would go with A. No point in this one. Any metal part of the vehicle, that is a potential answer, but again, because of the modern cars, that might not always be the answer. So in this case, the safe one to do is A. How much voltage does a mobile transceiver usually require? In this case, it's A. We know it's 13.8, but we're gonna go with A. Which of the following battery types is rechargeable? Nickel metal hydride, lithium ion, lead acid, all the above. All the above. See, this section has a lot of all the above, the previous one too. Which of the following battery types is not rechargeable? A? I'm thinking B. So I don't think even carbon zinc are made anymore. But lithium ion, yes, definitely rechargeable. Lead acid car battery, definitely rechargeable. Nickel cadmium, NiCads. So if I say that as NiCad, you might now recognize that as a rechargeable battery. So it's carbon zinc.
NiCads have a memory effect on it too.
Yeah. What type of circuit controls the amount of voltage from a power supply? A. What can happen if a lead acid storage battery is charged or discharged too quickly? The battery could overheat, give off flammable gas. The voltage can become reversed. The memory effect will reduce the capacity of the battery. First of all, I don't think all these choices are correct. A. There can be a flammable gas unexploded, so be careful about that. All right, now let's take a break. We got 1 hour. I want to go back over to chapter 4 and
Actually,